My name is Dr. Venu. I'm working as a professor in the Department of Civil Engineering at Institute of Aeronautical Engineering, Hyderabad. So today I'm going to discuss about a design of steel structures and drawing codes. And this is just a basic introduction about the codes. And in these codes, we see how many modules are there and what are the different modules contains. And we see what is the prerequisites of these course, as well as the what are the course outcomes, what are the course objectives. So all these things we'll see today's lecture. So let us see one by one. So the prerequisites of for this course, so you should have to study mechanical materials, center materials, and structural engineering. So here structural engineering is nothing but structural analysis. So these three are the basic subjects for the design course. Any design course, you should know, you should understand, you should able to calculate the shear forces and bending moments. So these three subjects, prerequisite subjects, will cover all these shear forces and bending moments of different beams, especially determinate structures as well as indeterminate structures. So the course overview, if you see the course overview, design of steel structures and drawing deals with the analysis of various structural elements like tension members, compression members, beams, and girders, analysis and design. Both we'll see in this course. So this course will focus on mechanical properties of the structural steel and what are the different steels available and what are those properties, how we can use those steel into the design purpose, and what is the concepts of elasticity, what are the limit state design, what is limit state design, how to go about the limit state design, how to design the different members, structural members in the steel structures. Okay, and this course will help to enrich the knowledge of the design of multi-storied as well as industrial structures and bridges. So this entire course deals with the steel only. So this is just like reinforced concrete structures. There are reinforced concrete structures. So in that subject, we will design the concrete structures, but here in this course, so we'll mainly focus on only steel structures. And what are the course objectives? So this course, after completion of this course, the students will try to learn the concepts of limit state design and the behavior of structural steel used in the design and its properties. And second one is the design of structural elements necessary for creating efficient and economic steel structures. So as a structural engineer, we should see that the cost of the structure should be economical and efficient. So these two things we need to take care as a structural engineer. So the design and drawing of multi-storied, third one, the design and drawing of multi-storied industrial residential structures, including bridges, for creating high performance and durable structures. So after completion of this course, you will be able to learn all these three. So this is the main course objectives of this design of steel structures course. And if you come to the course outcomes, so entire course outcomes has been divided into 6 outcomes. So after completion of this course, so you will be able to know all these things. The course outcomes we'll see one by one. So CO1 is recall the concepts of structural steel properties and different loads and their combinations for understanding the behavior of steel structures. So here you might have studied already in strength of materials what is the steel and what is the mild steel, what is the stress strain curve, what are the different properties of the steel. So you have to recall all those things and you need to understand what are the different loads acting in the structure and what are those combinations. What are those combinations? So you should be able to understand while completing the first CO. Then come to the CO2. So explain the concepts of limit state design different limit states and design strengths, deflection limits, and serviceability requirements for the designing of steel structural elements. So, if you come to the design part, you should able to understand what is limit state design. So, for this entire course, we are going to deal with the limit state design. And what are the different limit states? What are the different limit states? How to find the design strength of existing members? How to find out how much load it is going to take? And what are the deflection limits? Different deflection limits. For example, if you consider a beam or a column or slab, so there will be different deflection limits will be there. So we have to check after designing the structure. We need to check whether that the deflection is within the limits or not, as per codal provisions. And serviceability requirements also we need to check it out. Let's come to the CO3. So design bolted and welded connections for joining two or more steel structural elements for the transfer of loads. So for example, if you come to CO3, so we need to design the connections. So for example, if you take a small plate, so if you want to connect two plates, so the two plates has to transfer load one plate to another plate. So you have to design that connection between these two plates by using bolts as well as welds. So you can use any one of these bolts or welds. So these we need to design. And let's come to the CO4. So design of tension members, compression members, like columns, beams, and girders using Indian Standard Code method. So we have to design tension members, compression members. So compression members includes columns, beams, and girders using our Indian Standard Code methods. So Indian standards, we have some Indian standards we need to follow while designing these structural elements: tension members, compression members, beams, girders, all those things. So let's come to the CO5. So design eccentric connections with brackets, beam end connections, web angles, truss joints for large crane movements in industries. So especially these eccentric connections with brackets. So for example, if you take a granite industry, so the movement of the crane should be there horizontally, right? So we have to design the brackets. So those brackets, how to design those brackets? So that we will see in course outcome 5. And beam end connections. So beam to beam, that's what I'm saying. So beam to beam connections or beam to column connections, and the truss joints. So if you have a triangular truss, so there will be so many members in the truss. The minimum members in the truss is 3, and it can be a 4 or 5 or 6 or so many. Right? So we have to design these truss joints. So that we will see in this outcome. And the last one, and but not the least, and the design of plate girders. So design of plate girders with and without stiffeners for designing bridge structures, very large span beams. Right. So plate girder, it is nothing but a beam. But it is having very large spans. For example, beam might be 3 to 5 meters or 8 meters or 10 meters. But if you consider a plate girder is nothing but very large span, that is 30 meters, 40 meters, 50 meters, like that. Right? So these are the course outcomes. So after completion of the course, so you will be able to do all these things. So let us see the syllabus. So module 1, it is comprises of these topics. The module 1 is introduction on mechanical behavior of the steel. So in this module, we are going to cover the materials, what are the different materials available in the market, and what is making of iron and steel, and the types of structural steels, mechanical properties of the steel, concepts of plasticity and yield strength. So what is the plasticity and what is the yield strength? And what are the different loads and their combinations. So we have so many loads, and how to take the combinations. We cannot consider all the loads at a time, and what are the different combinations we need to consider for the design purpose. And wind loads and roofs, how to calculate the wind loads and roofs, and what is the behavior of the steel if it is subjected to the loads, what is the local buckling. So buckling is very, very important in case of steel structures. Then concepts of limit state design, and what are the different limit states. Generally, we will take care while designing the structure as per IS 800 2007. So this code IS 800 2007 is very, very important for this course. So we need to follow the guidelines of IS 800 2007. And the design strength. So how to calculate the design strength of existing structures or existing elements. So for example, if you take a L section or I section or a channel section, how much load it is going to take, So that's what we are going to see, how to calculate the strength of that members, and what are the deflection limits. What are the different deflection limits? So, for example, if you have so many structural elements like tension members, compression members, right? So, what are those deflection limits? Maximum deflection limits. So, while designing the structure, the elements, whatever we have designed, so those elements should not cross the maximum deflection limits. So, if it crosses the maximum deflection limits, you have to redesign the members. And what is the serviceability requirements? What are the serviceability requirements of the steel structure? Bolted connections, we'll see welded connections, and what is the efficiency of the joint. So after designing the joints, what is the efficiency of that joint? How much load it is going to transfer? So those things we will see while doing the problems, right? So what is the prying action? And what are the different types of welds? And even bolts also we have to see what are the different types of bolts. And the design of tension members and the design strength of members. So these will cover the first module. So first module is comprises of the basic introduction about all those things. What is the steel? What are the properties of the steel? And what is the limit states? What are the different limit states? What are the loads and the load combinations? So after that, we will see the bolted connections as well as welded connections. We have designed those welded connections, and tension members and their strength of the members. So let's come to the module 2. So module 2 is compression members. So in this module, we are going to design the compression members. So compression members, it includes the columns also. So compression members will have two types. One is the columns and the other one is the struts. So depending on the requirement, we will call that as a strut and column. So if it is generally struts we use in the trusses. So design of compression members. So buckling class, what is the different buckling classes as per IS 800 2007. So we have 4 buckling classes: class A, class B, class C, and class D. What are those classes? How we have to go about how to consider which class we need to consider for the design. And what is the slenderness ratio? Slenderness ratio is very, very important in case of compression members. What are the limits of the slenderness ratio? And strength design. So that's what the existing members. How to find the design strength? How to find the design strength of the member? If the member is used as a compression member or a column or a strut. Right. So what is the laced column? What is the battened column? So those things we will see in combustion. How to design these laced columns and battened columns and column splices, column base and slab base. So in the module 2, we are going to cover the combustion members. So that is design of columns, substructs, and the connection between the column as well as the foundation. Column as well as the foundation. So here, if you see here, column base and slab base. So column base and slab base will deals with the foundation. How to connect the column to the foundation level. How to connect the column to the foundation level. So we have two types of bases. One is slab base and other one is a deserted base. So those things we'll see while covering the module 2. And the module 3 is comprised of beams. So here in the module 3, we are going to see what is the different beams, how to design the beams, how to calculate the plastic moment, what is the bending and what is the shear strength, what is the bending strength, and what is the laterally supported beams, what is laterally unsupported beams, what are those beams, how to design those beams, and design of built-up sections, and large plates with web buckling, web crippling, what is web buckling, and deflection of beams and design of purlins. So this entire module 3, we are going to cover the design of beams. Right? So here we have two types of beams. One is laterally supported beams and laterally unsupported beams. So how to find out the bending strength, how to find out the shear strength to the laterally supported and laterally unsupported beams. So design of purlin also it will include here. So design of purlin. So generally purlins we will use in the sheds to connect the two trusses. We will use the purlins. So those purlins also we need to design like a beam. So generally all the beams will be subjected to single axis bending. So only one axis is going to take the bending. But in case of purlins, both the axes, z axis as well as the y axis, both axes will have the bending. So this design of purlin will be somewhat different from the design of beams. So these purlins we need to design like a subjected to biaxial bending. So this we see in module 3. So if we come to the module 4, so module 4 is eccentric connections. So design of eccentric connections with brackets. So especially that's what I told you. If you have a industry, so movement of granite rocks will be very very heavy loads, right? So this we need transfer to one place to another place, which means you have to design the crane. So those crane wheels should be supported in brackets. So column, we need to design those brackets. So here we have two types of brackets. We have two types of bracket connections, type 1 connection and type 2 connection. Those we will see while discussing in module 4. So beam connections, what are the beam connections? Beam to beam connections, beam to column connections, and column to foundation connections. So connections are very very important in case of steel structures. Right. So what is unstiffened connection, stiffened seated connection? So how to design these unstiffened seated connection, stiffened seated connection, and how to design the truss joints? How to design the truss joints also we will discuss in module 4. So in the module 1 and module 2, we will design the members in the trusses. If we come to design of truss joints, so after designing the members, that is compression members and tension members in the truss, so we have to connect these compression member and tension member in one joint. So how to design those joints? In trusses? How to design those joints in trusses. Means the one member will be subjected to compressive force and the other member will be subjected to tensile force. So that combination of compression member and tension member, how to connect those two members in a single joint. So that we are going to see in module 4 and module 5. So design of plate girders. So that's what I told you in the previous slides. So plate girders, generally we will use the plate girders for the larger spans. We'll use the plate girders in the larger spans, that is 20 meters, 30 meters, 40 meters. So especially if you see the bridges, so we'll have very, very big girders. So those things are called girders. So girder is nothing but a beam. But here the span is very, very large. And the readily available sections are not so readily available section. If it is not available, so then we have to see the. So module 5 is we'll talk about plate girders. So that's what I told you in the previous slide. So the plate girders is nothing but a beams, but the span of the plate girders, will be very large, 20 meters, 30 meters. 20 meters or 30 meters. Especially these type of girders you're going to see in bridges, steel bridges. So where you can see very large spans. So old railway bridges, if you see old railway bridges, will have the very large spans, right? So in that cases, we will use the plate girders. So one more thing here, plate girder is these girders are made up of only plates. So readily available sections. Means, so for example, I sections will be available readily. So if those readily available sections are not sufficient to transfer the loads, then we have to design our own section by taking different plates and different thicknesses. So those things we are going to study in module 5. Right. So design of welded plate girder. So we can use the welds or we can use the bolts. Right. So here we are going to take the different plates. So if you want to form a I section, we have to take the 3 plates. We need to take the 3 plates. So one plate here, and one plate here. So this is 1, 2, 3. So these are the 3 plates. So we need to connect these plates also, right? So how to connect these plates? So we can use the welds or we can use the bolts. So that is up to the designer. So designer will take the decision. So he can go about welds or he can go about the bolts. And see what is the optimum depth and how to find out the optimum depth of the plate girder. So and design of the main section, how to design the main section, that is 2 flanges and 1 web section. How to design those main section. So design of end bearing stiffness and intermediate stiffness. How to design the end bearing stiffness, how to design the intermediate stiffness, how to find out whether these stiffness are required or not, right? And the connection between web and flange and connection between the stiffness, bearing stiffness to the web, end bearing stiffness to the web portion, and intermediate stiffness to the web portion as well as the flange portion. How to design those connections. Even splices, web splices, flange splices, the plates, if it is the plate. So for example, the span of the beam is 40 meters, but plate is available only 20 meters. The maximum length of the plate is available only 20 meters. So remaining 20 meters, so we have to connect 2 plates. We need to connect 2 plates. So even for the web portion also we need to design, and flange portion also we need to design. So those things we will see in module 5. And the textbooks generally we'll use for these course. SK Dundigal limited design of the steel structures, and N. Subramanian, design of steel structures, and Bhavketi for the design of steel structures. So especially we are going to follow this SK Dundigal book, limited design of the steel structure. So if you want more information about the behavior of the structural steel and different members, so you can refer N. Subramanian. So N. Subramanian is a very good book. Bhavketi. So Bhavketi is generally it contains only maximum problematic only problems, and there are the reference books, case Sairam, Gellard and Gellard, and Ramchandra. So Ramchandra, design of steel structures, it is having volume 1 and volume 2. So these Ramchandra is also very good book, very good book, and very old book. And for this course, we are going to follow this SK Dundigal book for the further lectures, right? So they are the textbooks and the reference books generally we follow for this course. So there are the web references, so you can refer NPTEL videos for this course, and the books, the freely, readily PDF books also available for this course. You can download and you can study, right? So this is about just introduction about design of steel structures and drawing. So let's begin with module 1, introduction on mechanical behavior of the steel. So introduction on mechanical behavior of the steel. So in this module, so we are going to cover what are the different materials generally we use for the design purpose, and what are those properties, what are the properties of the different steels, and what is the making of iron and steel, making of iron and steel. So further, but it is not included, but you should know as a design engineer, as a structural engineer, you should know how they are making iron and steel, and what are the different places in India where they are making the iron and steel, and what are the mechanical properties of the steel. So those things we'll discuss today. So these are the advantages of the steel structures. So what are the advantages? Why we need to see the steel structures? Why the client has to go for steel structures? So first one is the strength. Strength is very high. Strength is very high when compared to RCC structures, right? Speed of erection. So speed of erection is very important here. So you can build a steel structure, 10-story steel structure building within a week or within a week. So speed of erection is very fast. So in case of steel structures. So prefabrication. So we'll have the prefabrication. So fabrication work we can do at the shop and take to the site, just assemble it, so over. So that is the steel structure. Demountability. So demountability is also very easy in case of steel structures. So demountability means just removal of the members. Just remove the bolts or cut the welds. You can remove entire structure within minutes. Entire structure within a day, within a hours. Entire structure. So demountability is very easy and easily recycled, and hence it is greener than the concrete. So easily you can recycle the steel easily, right? So it is greener than the concrete. But in case of concrete, we cannot recycle the concrete, right? And the steel structures are handled by trained persons in the factory. So steel structures handled by a trained persons in the factory. So you will get a better quality control than the concrete structures. So these steel structures will handled by a trained persons. Untrained persons, they cannot handle the steel structures. So only trained persons will handle the steel structures in the factory. So you will get a very better quality control than the concrete structures. The concrete structures, we may or we may not achieve the uh, quality, but in case of steel, very well trained persons will be there in the factory, right? So we can assure that we will get 100% quality control in the steel structures. So this is a schematic diagram, schematic diagram of the steel making or iron making. So first, limestone, iron ore, and coal. So this is the first part. So from this, so all these will go to blast furnace. So blast furnace to oxygen steel process. So here blast furnace to oxygen steel process, or you can here the scrap also will include here scrap to electric furnace. So both the from the limestone and iron ore and from the scrap you go to pouring cylinder. From the pouring cylinder you will get the continuous caster. You will get the one continuous caster, means you will have the 16 mm diaboards, plates, so everything will have the continuous caster. So in other part it will go to ingots, so ingots to soaking pits to bloom mill, so bloom mill to our wide flange beam mill. So here wide flange beam mill, so here if you see here, so you will get the I sections, L sections, channel sections, angle sections, everything will be coming from here, this part. So this diagram has, this is the reference for this diagram, you can refer for this. So this is the schematic diagram of entire steel making process. In industry, steel making industry, so this is the schematic diagram. And this is the plants, major plants in India. So we have Bhadravati, Vishakhapatnam, Rourkela, Bhilai, Jamshedpur, Bokaro, Durgapur, and Kanpur. So these are the main steel making plants in India. And then the mechanical properties of the steel. So why we are going for steel structures, and these are the main mechanical properties of the steel. Ultimate strength is very high in case of steel structures. Yield strength is also good, and ductility. So steel is a ductile material. So you will get a very good warning before failure. Weldability, so you can easily weld, and toughness. So toughness will be there. Corrosion resistance. So right now the lot of steels available for the corrosion resistance, and the machinability is very easy in case of steel structures. So these are the important mechanical properties of the steel. So due to these advantages, we are going for steel structures. So thank you for your attention. So especially in this lecture, we have learned and what is the steel structures, and what are the prerequisites for this course, what are the course objectives, and what are the course outcomes, and what are the syllabus. So how many modules? The entire syllabus has been divided into 5 modules, different modules, right? 5 modules, and we have learned what is the properties, what is the advantages of the steel structure, and what is the schematic diagram, the flow, steel making, iron or steel making, right? And what are the different places generally available within the India. So next class we are going to cover what is the different loads and their combinations. So thank you very much for your attention.
Like, share and subscribe. Hit the bell icon for more updates.